Hi friends, so we are going to see today the lecture number 3, that is the bars subjected to varying loads in the simple stresses and strains. Now before going to this problem statement, normally in this type of problems they ask to determine the deflection of the given bar, and to determine this deflection of the given bar they will provide you the number of forces. So just see in the problem statement, here they have given the 50 kilonewton load, here they have provided the 80 kilonewton load, here they have provided the 20 kilonewton load, and here they have provided the 10 kilonewton load. Means they will provide you the load which is varying throughout the cross section, and they will ask to determine the elongation. So in such numericals we will have to use the formula by using the Hooke's law. So first I will write here the Hooke's law. Now what is this Hooke's law? In the Hooke's law, the stress is proportional to strain. So the stress will be equal to modulus of elasticity into strain. So this modulus of elasticity is nothing but the proportionality constant. Now what is meant by stress? Stress is nothing but force divided by area, and strain is nothing but change in length upon original length. So I have represented the change in length by delta. Okay. So if I want to determine this delta, means change in length, then the formula will be FL divided by AE. So transfer this E and L on the other side, we will get this formula. So this is the formula to determine the elongation. Now just read out the statement of the problem which is given. A brass bar having cross section of 1000 mm square is subjected to axial forces shown in figure. So they have given the number of forces along with the lengths, and they have already provided the cross section. Find out the total elongation of the bar, and for that they have given the value of E. Now to solve such numericals, see here, in the AB section the force value is different, in BC section the force value is different, and in CD section the force value is different. And we know the formula for the elongation, so delta is equal to FL by AE. So as the forces are varying or changing in each section, so we will have to determine the elongation of each section separately, and the total elongation of this bar, or total deflection you can say, this total deformation of this bar, we can say that change in length for AB, for change in length for BC, plus change in length for CD. So if I add the change in length of each section, then you will get the total deformation. So I will write this as equation number 1. Now as the force is varying, so we have separated each section. Now determine the change in length for each section. So to determine this one, we will have to determine the force in each section. But we don't know the force in AB, force in BC, and force in CD. So for that we will have to determine the forces in each section. So I will write forces in each section. Now how to determine these forces? Just follow the steps, whatever I am using, you will get the answer. So cut this bar into the 3 sections, because they have given the 3 sections. So I have cut this bar into 3. So the first one is AB, second one is BC, and third one is CD. So I will write here AB, this is the first one, BC, which is the second one, and CD, which is the third one. So I have cut into 3 sections. Now how to determine the force in each section? See, you can start from any one end of this bar. So we have 2 ends, either A or B. So you can start from A or B. So I am going to start for this problem from the A end. So you have to keep the force which is at end A as it is. So that force is on left side. So I will keep the same direction and the same force, that is 50. Okay. So write down the force as it is from any one end. Either start from A or from B. I am starting from A, and I have kept the same force as it is at end A. Now the next step is write equal and opposite force at B. Means whatever the force you have written here, draw the opposite direction and write the same force. So here I'll write the 50. Equal and opposite at B. Now if you see your main figure, this one main figure, and the whatever the forces that we are writing here, see this B section we have split into two, the first B and the second B. Means I have split this B into two. So if I add this force and force here, then the total will be equal to which is given in the problem. Okay, so we don't know force here, so we'll have to consider one force at this B. So consider any direction. So I will consider towards left and the force value as x. So consider at this second B the force towards left and the force value is x. Now I'll write here at B. See, the addition of these two B forces will be equal to given in the problem. Okay, because we have splitted this 1 into 2. So we have to add these two to get the answer of this one. Okay, so add these two forces. So 50 which is on the right side, then minus x which is on the left side will be equal to 80. See, this 80 is on right. So the addition of this 50 and x will be equal to 80. So that I have written here. Now determine the x. So transfer this x on this side and transfer 80 on this side. So this will become 50 minus 80. So x is equal to minus 30. So the value of this x force is minus 30. But whatever the direction we have considered is wrong, because the answer is minus. Means we have considered the wrong direction. Means this direction is wrong. Means it is in opposite direction. So I'll correct here. So the force towards right and its value is 30. See here, this minus sign indicates, the minus sign indicate whatever you have considered is wrong. Means the left side that you have considered is wrong. It is not on the left side, it is on the right side. Okay, means here negative sign indicates your assumed side is wrong. So you have to keep in this mind that the side that you have selected towards left is not towards left, it is on right. Okay, now write equal and opposite to this force. So equal and opposite, opposite means it will come in this direction and the value will be 30. Okay, so we got the force in section BC. Now go for the section 3. Now in section 3 consider any direction. Consider any direction. I'll consider towards left. Okay, and I'll consider this force as y. So at C, now we are solving for C. See, initially we have only one C. We have splitted that C into two sections, this first one and the second one. Now if I add these two C sections, then the total will be equal to the problem, the C value, force value which is given in problem. So add these two. So this 30 is towards left, then y is also towards left. So minus 30 minus y will be equal to the value which is given at C. Which is given at C. It is 20, but it is also on left side, so it will be minus 20. Now solve this one to get the value of y. So transfer this y here, transfer this minus 20 on that side. So minus 30 minus 20, plus 20. When I transfer this minus 20 here, it will become plus 20. So y will be equal to minus 10. Now the answer is minus, means whatever the side I have considered or assumed, it is wrong. So this side I have considered is wrong because the answer is negative. So it will be in opposite direction. So the force will be in this direction and its value is 10. Now write down equal opposite force here. So it will be 10. And just check this one with this one. If these two values are correct, then whatever you have solved is correct. Okay, means after solving we got three sections. See, I will draw here again. The first section is AB, and in AB just see the forces. These forces are tensile and it is 50 kilonewton. See for BC, just check the direction of force. The force value is 30 and it is compressive. Check for CD. If I check for CD, again the forces are compressive and its value is 10. Means the first section is tensile, so I'll write here T. The second section is compressive, so I'll write here C. The third section is again compressive, so I'll write here C. So this is my final forces on AB, on BC and CD. Now we have the forces in each section. Now by using these forces you can determine the total elongation. So from equation 1 again I'll write total elongation delta, which is equal to change in length in AB plus change in length in BC plus change in length in CD. But I have not written plus. Why? Because AB section is tensile, so its length will increase. BC section is compressive, so its length will decrease. So here you have to write the negative sign. Again check CD. The CD section is also compressive, so its length will decrease. So here we have to write the negative. If it is tensile, write positive. If it is compressive, write negative. So this is the addition of AB, BC and CD. Now we have the forces in each section, so directly we can put the formula. So I'll write the formula. FL by AE for AB section minus FL by AE for BC section, again FL by AE for CD section. So just put the value of force, length, area and modulus of elasticity, will give the total elongation. So I am going to put the value. See, the force in first section, it is 50 kilonewton. So 50 into 10 raised to 3 Newton into length of AB. Just go to problem statement and check the length, and this length is for AB it is 600. Okay, so the length is 600. 600 divided by area. They have given in the numerical, it is 1000 into modulus of elasticity. They have given 1.05 into 10 raised to 5. 1.05 into 10 raised to 5. So this is for AB. Now write for BC. For BC the force value is 30. So 30 into 10 raised to 3 into, check the length of BC. Length of BC is 1 meter. So we have kept all units in mm. So it is 1000 mm. 1 meter means 1000 mm. Then area, they have given 1000 mm square into modulus of elasticity. The material throughout is same. So it is 1.5 into 10 raised to 5. So this is for BC. Now I write for CD. The force value is 10 into 10 raised to 3 because it is in kilonewton. Just check the length. So length of this section is 1.2 meter. So it is 1200 divided by area 1000 mm square, which is given into the length, the modulus of elasticity, it is 1.05 into 10 raised to 5. So here I have entered all the values from the formula. Now if we solve this one on calculator, we get the answer. The answer for this first bracket is 0.2857, 0.2857. If I solve the second one, the answer is 0.1904, 0.1904. And if I solve for this third, then the answer is 0.2095, 0.2095. Now solve this one, you will get the total change in length, and its answer is minus 0.1142 mm. Means with the application of this force, the change in length is minus. Here negative sign indicates it is compressive. Compressive means the length is decreased. Okay, means the final change in length is 0.11 and which is reduced. Okay, so to solve such problems, means bar subjected to varying load, you can use the simple formula change in length, that is delta is equal to FL by AE. But we will have to determine the forces in each section, and I have shown how to determine the force in each section. If you know the force, you can directly put into formula, you will get the answer. Thank you.